Good evening, everyone. Thank you all for joining us this Tuesday evening here. And we have a great speaker for you all this evening. First thing I want to do is talk about recent events. And obviously, this past Friday, we've had a lot of significant tornadoes tear through East Texas into Oklahoma, and Arkansas, and Louisiana. And some of us here have personal connections to some of the impacts to it. So it's been tough, and our hearts go out to everyone who is impacted with that. And then for upcoming stuff, we have Tropical Storm Nicole heading for Florida. Last thing that Florida needs at this point is another tropical cyclone. So they're forecasting for a hurricane tomorrow. So hopefully everyone will be okay there. So now, without further ado, I will present to you our speaker, who hails from Maryland and then decided to go all the way to the other side of the country to go to school. She got her bachelor's in geological sciences from the University of Southern California. And then after an internship at the National Severe Storms Laboratory, she enrolled at OU and got her master's in meteorology from the University of Oklahoma. And for the last 8+ years now, she has been with the University of Oklahoma, the Cooperative Institute there, CIWRO, and the National Weather Service Warning Decision Training Division, where she is a training rock star. So without further ado, I hereby present to you Jill Harden.
Well, thank you, Steve. And I should preface that the only reason I have the title of training rock star is because Steve left his job and it opened, and I was fresh out of grad school and was like, oh, this sounds fun. And so I can actually say that my career is because Steve decided to leave. So I owe it to Steve, who also did leave a great legacy for me, a good starting point for me to take over. And so that's how our connections have been made. So I do see some familiar names and faces here. So thank you for having me at your chapter meeting, and to echo Steve, I have been thinking about Texas and you all from Friday's event. So hopefully everyone's okay, and the communities are doing all right. Out of curiosity, if anyone who's on the line or in the room, how many of you are familiar with the Warning Decision Training Division or have heard of it before? Okay, I see a few hands. I don't know if the people on can use the raise your hand feature or not in Zoom. Okay, so what I do is maybe known for some of you, so I won't belabor some of the points. The fun part about today is I'm going to show a warning demo. And so how many of you are familiar with the process of issuing a warning using the National Weather Service's program, AWIPS, and its warning generation programs? Okay. So there might be some folks that are here to learn, some here to hear the same thing. So hopefully it's still interesting. Amanda, I hope so. Or Hazard Services in your case. So anyway, without further ado, as Steve said, we'll kick it off. And so he kind of introduced it. I'm originally from Maryland, East Coast girl, but decided to check out what the West Coast looked like. So I moved over there. They didn't have meteorology, and so I was interested in it still. I ended up studying earthquakes because I was like, I'm in LA. I might as well study something cool out there, and that's earthquakes. And so, but I was still interested in meteorology. So that's when I said, all right, I'm going to do this hauling scholarship, and I'm going to just go to Norman. Whatever they can give me in Norman, I'll take it because I just want to be in the weather hub. And so those were my advisors listed there. And that kicked off kind of my love for meteorology and deciding I need to do this as a master's and then a career. And so the flash flood portion, that I have a hydro background, and it's because I worked in, quantitative precipitation estimation for my hauling scholarship. And then as a master's program, Dr. J.J. Gorley saw my geology background and said, hey, you've got some ground background. I mean, now you're getting some air background, and flash flooding is the perfect mix of the two. So that's where I came into WDTD as kind of their flash flood training focal point. And that's what I've been doing for the last 8 years. So WDTD, our job is to train National Weather Service forecasters on warning decision making. And so our audience is the 122 forecast offices around the country. And there's about 10 to 15 forecasters per office. So we have a lot of folks that we have to train, and we have multiple ways of doing it. Oops. here's kind of the structure of a forecast office for those that might not be as aware of kind of the structure of it. There's, management, then there's the forecasters, and then some, a hydrologist, some technicians, administrative staff, and so on. And so in my role, we really collaborate very closely with the local training officer, which is the one in blue called the Science and Operations Officer, the SOO. And a lot of times they're the local training focal point. They're who decides what the office needs in terms of local training, and they're also our partners in knowing what the field needs for training, and what are the objectives that we need to fulfill. And our audience is then directly the senior and lead forecasters, as well as general forecasters, again, in helping them with warning decision making. And so they, the science and the operations officer is not only the training liaison, they're also doing research to operations and incorporating new science and technology into their offices, developing new forecasting techniques, ensuring good quality of their products and services, and professional development opportunities. So we work very closely at all of those 122 offices. This is kind of our liaison. And so there's us, we do the national level training. There's about 2,000 forecasters that we have to, kind of keep in mind as we're developing training. But then there are regional centers around the country that focus on their particular regional needs. Like Western region, might have a lot more burn scar related flash flooding concerns. Eastern region might focus more on tropical weather. And so they kind of have their needs and their specialties. And then again, that local office, they really focus on exactly what, Caribou, Maine might have a great winter training program, for instance. And hopefully, the Florida offices have been spun up on their tropical stuff for, going into these events. And so we all work together, we all talk, we all decide what the needs are, but ultimately we have the highest level, and we kind of have to have the broadest reach as we develop our training objectives. And so who are we? We're WDTD. We're part of the Office of the Chief Learning Officer. It's kind of a redundant name sometimes, but there are a bunch of offices around the country. The Forecast Decision Training Division is in Boulder, and then the NWS Training Center has 3 divisions in Kansas City: a Leadership Academy, Electronics and IT, and then Decision Support and Communications. Then there's us in Norman, Oklahoma, focusing on warning decisions, and then we have some headquarters staff out in Silver Spring, Maryland. And so, as the name implies, we focus on warning decision making. Here, we do tornado, severe thunderstorm, flash flood, winter. Those are kind of some of our bigger topic areas. And then we have a bunch of kind of satellite topics beyond that. And so we focus on science, technology, and human factors. When I do this outreach talk to, schools and stuff, they might think, well, you go to school for meteorology. What do you need training on? You know everything from having gone through school. Well, we all know there's on-the-job training. There's certain needs that every, job requires. And so the science is always evolving. So we're trying to keep up with that. Technology is definitely always evolving. Steve's a big proponent of that at his job. And then the human factor side, these are humans making decisions on whether to warn and not warn. And we, provide insights into the human side of the process as well. And so how do we train? Again, we have to have a broad reach. We have to be able to reach all the way to Guam and all the way over to Puerto Rico and to Caribou, Maine. And so we do a lot of online development. We have lessons that we record, and forecasters can log into what they call a learning management system, or LMS, and be able to take trackable lessons. I see a question came in. I can go ahead and pause for a hand raise if someone has a question. Or maybe that's still left over from when I asked my question. Not sure. I just noticed it. So I can carry on. And so we do a lot of online lesson development. We do a lot of webinars and what we call instructor-led training, which is basically an interactive webinar. It's not just a passive sit back and listen. It's, we're going through case studies and we're asking questions. We're doing it in small group settings where forecasters can really interact and see the applied nature of the data. And so that's a good bulk of what we do. And then what we love to do is a lot of the weather event simulation and the in-house workshops. This is where you really can get more hands-on application. And it's where, we can see differences being made, because kind of like a pilot goes through a flight simulator, we consider our weather event simulations the same thing for forecasters. It's the ability to practice with hands-on data and be able to do it in, a case review mode before having to go do it live in operations. And that's what we're going to talk about during our demo and showcase in the later part of today's talk. And so, we also are able to host in-house workshops. Our main course that offers that is for our, entry meteorologists that are coming in and needing to get spun up into the weather service and warning operations. And so I'll show some slides related to that particular course, but that picture there on the right is actually our lab here in Norman where we host those workshops. And that's a great opportunity for us because we get to see a lot faster development. It's a lot nicer to be in the same room where we can point to the screen and talk through the decisions that forecasters are making. We have 5 days and we can make, a lot of progress in that time when they have the dedicated training shift with us. It's not on the job trying to do other tasks in operations or on a midnight shift. It's really their time to focus in on training and really be with us and hear the feedback and make, progressions every day of the workshop. And it's incredible to see on a Friday, we ask, so how do you feel? And they're like, it's so automatic now. It's so, I really feel like I can do this. And I feel like, Monday was, forever ago. And so we love being able to get those face-to-face and that time with forecasters. Oops. And so here's kind of the training progression that in the weather service. We start with kind of our foundational training. Everyone goes through the basic radar and applications course. That's our foundational course, one of our flagship courses at the Warning Decision Training Division. And then, there's other foundational trainings. It's about acquainting with the tools available, the satellite, for instance, and other NWS technology that's just critical for their job duties. After they get those base level trainings where they can get acquainted with all of the tools and technology, then you go up into this advanced training, some more of the specialized topics. And so, we focus on severe warnings. I do the flash flood course. There's also winter courses. Human factors, communications is done in our Kansas City division, and then all those kind of subtopics there that you can see. So, again, these are all kind of getting more specialized, and we have kind of those advanced courses that focus on them. And then ultimately, ideally, we're keeping up to date with these courses and this expertise, becoming more of an expert with time. And so seasonal training, we call it seasonal readiness training. It's really kind of like the updates, the things that, every year when new stuff comes out, keeping up to date with it, getting that practice, doing those case simulations regularly. And then the extra training where it really comes into play to be the focal point in the office. You see folks leaving some of these foundational and advanced training courses and really wanting to be the hydro, focal point for their office. And so then they're taking that next level up. And there's also a leadership academy training on how to be a leader in the weather service as well. And that's again done through one of our Kansas City divisions. And so ultimately, the NWS mission is to protect life and property. And so, a forecaster must be able to not only identify the threats, but also be able to communicate the important information. And that's where kind of the training division has that holistic approach to what we offer. And ultimately, they need that information to be actionable to the partners and the public. And so, knowing what are the impacts and what do partners need to know to make those decisions are important things a forecaster must, be able to do and take into account. And they have partners at every level, local, state, national, from emergency management, public safety officers, media, and so on. And so just to give you a flavor of some of the courses that we offer, this is our radar and applications course. And so this is our, again, flagship foundation course. Steve trained on this back in the day when he was at our division. It was called something different back then, but same thing. And so these are some of the topics within the course. You start with kind of AWIPS fundamentals is what we call it. That's the software that forecasters use to ingest, process, look at data, and then ultimately issue their warnings. And then we go into introduction to the radar and its principles. It's how to interpret velocity data, the products that it has within the radar's output, and then the applications of it. All right, now that you know how to interpret velocity data, what does that mean for a convective storm? What are you looking at? How does that show the evolution of a storm and where the different sectors of a storm are and what they mean for different threats? There is a flash flood topic, and then ultimately the foundations of the warnings themselves. And you can see we have sprinkled in webinars. Again, we don't just say, here, go take this 80-hour behemoth course on your own and we'll see you in 6 months. We want to sprinkle in chances for them to interface with us and, really get a chance to ask questions at the parts that we know that the questions are going to be. So, what are these products and how do I interpret them? And what are the applications of them? And then flash flooding and, warning, what we call polygonology, how to issue a good warning with a good polygon and good text. And then you see at the bottom this thing called a workshop primer, and that's their first chance to get the hands-on practice. They get a case delivered to them at their office, and then they can kind of put it all together and go through a primer that before they show up to our workshop gets them a little bit of that hands-on practice so that when they get here, they're not rusty and they've had a chance to see some of the data and some of the programs so that when they can utilize the week that they have with us to the best of their time spent. And so here's just some pictures from our workshop itself. They finished that long, like I said, 80 to 100-hour course once it's all said and done. And it takes, I think a course runs about 3 to 4 months. And then they show up for our workshop at the end. And we, spend 5 full days, mostly in this lab. You can see this bottom image here. We do have a classroom where we have some lecture components, but we've really phased that down over the years because, again, their time with us is to get the hands-on practice. And so we have teams of 3. Each instructor has a group of 3, and all of their computers are connected so that they're issuing warnings as a team and they can see each other's warnings on each other's monitors. And so that also helps with some of the communication part of the warning process and handing off warnings between each other, talking about overlapping polygons and threats. It really adds to the complexity that they'll experience in operations. And so we have different cases throughout the week that focus on different things. Like we have flash flood labs that just give them a chance to deep dive into the flash flood process. And then we pick simulations that some have maybe more hail in them, some have maybe more pulse storms, some have more tornadoes, more wind. And so we try to give them a good variety because, again, they're coming from all over the country and sometimes over the world to come here and practice. So everyone's needs are a little bit different. After they go through that base foundational, how they use the radar and its applications, here are some of those advanced level courses, what we call our warning operations courses that have the more specialties. And so we offer 4 of them, human factors, flash flood, winter, and severe. And we have, a deeper dive into some of the more advanced topics for each of those courses. I want to pause here real quick and say that all of our material is available online. We are a government agency, and so we put all of our government, public taxpayer funded material online. And I know a lot of people reference that in students or people who are just interested in how to interpret radar data. And so I don't know if Steve, if you just want to send our webpage link out at some point after this, if anyone's interested in being able to access it and might want to just peruse some of the lessons that we've got out there. I mean, they are focused on forecaster needs, but I know that there are a lot of folks that enjoy just learning about the process and seeing what we've got. So definitely take a look if you like that. Here are some of the latest things that we've trained on in terms of tools and technology. We've, dual polarization technology has been incorporated into the radar for about 10 years now. And so we have, a lot of training on how to interpret dual pol products. MRMS and Flash, Steve knows this inside and out. This is what he works in now, the development of these tools, and we have training related to those applications. Tropical cyclone tornadoes is another example of a course that we've released that needs a specific need. 88D is the radar network. So there's build training that constantly comes out with new builds of the radar and what forecasters need to know related to that. Hazard services is also a very new warning generation tool in the Weather Service, and we have to use that to issue all hydro related products now. So flash flood warnings go out using hazard services, and so there's training on just how to use that tool to do those particular tasks. So I'm going to use the term AWIPS. You don't need to know the acronym. In fact, I would venture a guess that most forecasters don't know the acronym, but it's just the program that it's the holder of all data in product generation. It's basically what forecasters sit in front of day in and day out. It ingests almost every piece of data that a forecaster could need. It processes it, it displays it. There's built-in tools and overlays and everything that you could need to kind of interpret and make warning decisions. It's also used to issue all forecasts and watch warning advisory products, and it supports internal communication so that the Norman Forecast Office can help the Dallas-Fort Worth office if there was, communication, lags in their office, or for instance, if they had to shelter from a tornado, another office could pick up and issue warnings for them. So it's all this kind of internal telecommunication system as well. And that's what we need to mimic as a training division. This is their flight simulator. We need to be able to do this. And so with that, we've developed that weather event simulator, and it is our flight simulator for forecasters. And it basically mimics it almost exactly as best as we can in a simulated environment. We can access archive data and input it into the system to display cases, and a lot of local offices will do case studies on their own using their own weather event simulator. Every office in the country has one of these machines in their office. And then we have our whole lab full of them that I showed images of. And so there's abilities for those local training focal points to create cases that, maybe a big event happened and they want to know how they did, or they want to do an after action review of their operations. They can save that data, put it into the WES, and review it as an office. Similarly, we can send out the data. Usually right now it's with Blu-ray discs, and we can send cases out that forecasters can then take if they're interested in, say, my flash flood case that I released. It has the ability to do real-time simulations, and again, I'll show you that in a minute, as well as paused case review. Just hit the pause button just this time step. What am I looking at? What do I need to interpret? So that you can really do deep dives if you need to as well. And they've expanded its use quite a bit lately. It's in the hazardous weather test bed here in the National Weather Center. And have it, a cloud version is what I'm using now. And so that's a big development place in the Weather Service, is how do you do cloud simulations, because it is very labor intensive to move these large data sets around the country. And so this cloud development is huge right now, and it's gaining momentum, and it's great because we can get more cases out to forecasters who need the training. To simulate real-time operations as best as possible, it has a few different things that it can do. It has play, pause, and skip features. Again, think of it kind of as a video game that we can kind of move around as we need to. It also has a little window that offers timed reports. It's kind of the equivalent of if the phone rings in the office and you get a report of hail in such and such, it has the ability to display that report. It has the ability to map that report so that the forecaster can see exactly where that report came in and a little description of it. And then the program can also pull in other resources. We have hourly mesoanalysis come in that can help forecasters interpret the latest environmental data. And if SPC issued a updated convective outlook, we can have that SPC page pop in. And again, it's just a mock HTML page that we've created from their web page, but it gives the forecaster a chance to have those kinds of tools at their fingertips in this kind of one complete package. And so a month in the life of my job, my role at WDTD, there's lesson development. Generally, I'm always thinking of what flash flood training objectives need to be filled. So I'm reading up on maybe a new tool or a new paper that came out, collaborating with forecasters on the usefulness of that tool, finding out how it can help them in warning operations, and then creating a draft, narrating it, creating quizzes, publishing it, getting it reviewed, all of that to make a nice packaged up lesson. Additionally, I'd be instructing in these in-person workshops that we have for our radar and applications course, me in particular leading the flash flood labs and providing input as just a general instructor to my teams of 3. And then working on these kinds of simulations. I like to release simulations, every few years so that forecasters have new data to go through. And so choosing a good case study with good objectives, analyzing that case and figuring out when the good warning decisions are that they need to make, creating exercises for them to go through as they're going through the case to complete the various learning objectives that I want for them to get out of it. So I like the job because I can do kind of a variety of things all the time. It's always changing. There's always something new to train on. And so it keeps it interesting. So I think this is my last slide. So before I move into kind of our warning demo, I guess I'll take any questions if there's anything out there.
Anything here in the room or?
Okay, I have a question. One of my question is warning gen part of the AWEPS? I'm guessing it is, because that's the warning generator you use. Is that the same thing? And how is the watch warning? How is that, different whenever you do it? I know this is mostly on warnings, but a little bit on watches. Is that kind of done the same way, or how does that done?
Yep. So I will definitely be showing you warning gen in a minute, because we have an AWIPS demo that we're going to be doing on how to issue a warning. So you'll see that it is part of AWIPS. And the watch generation is slightly different. There's a different internal program in AWIPS that's not warning gen. And so it has a different flavor because it's kind of county based and it's gridded. And so it's called GFE if you're interested, but we won't be touching on that today.
Well, I say go for it, Jill.
All right. Well, then I'm going to switch to my other screen. So can you see my AWIPS display now? You can. All right. So here is AWIPS. Here is kind of the interface that forecasters see day in and day out. And so I'll just kind of go through a few of just the features of it to begin with. First off, I want to point out I have a case running. So here's kind of that simulation GUI. I pressed play a little while ago. And so the data has been kind of running in just like it would in operations. This is in simulation mode. It's supposed to mimic exactly what real time is like. And so that's been going for a little bit. In addition, we have the report generator I was mentioning. And so this is kind of where reports that we've added to our case can pop in at the specific times. And so the current time is 2213Z. And so it looks like a report just came in the case saying, emergency manager Ron Howard passes a funnel cloud report on through 3 miles northeast of Lahoma. So again, this is supposed to mimic as if someone was calling in saying, I just saw a funnel cloud here. And it helps forecasters get the verification that they need and to update their warnings or trim or cancel or whatever they would like to do with their products that are out there. Additionally, here's an example of the web pages that we also have pop in. This is the 22Z mesoanalysis page. And so it's meant to mimic exactly what is up on the SPC site. And, here's a convective outlooks page that we've created in HTML for. And so again, these are popping in periodically throughout a case so that forecasters can see the latest mesoscale discussions and so on and so forth. So it's really handy in kind of adding to all of the pieces that they would have in live operations. In AWIPS itself, again, I said it's the holder of all data and all product generation. So just taking a quick gander at the menus across the top, I like to point out, there's a whole menu just of tools. These are tools that have been developed by various groups throughout the years that, are supposed to help forecasters with, just even basic things, range rings, knowing how far you're sampling from a radar, to, again, distance tools, damage paths, unit calculators, all of these kinds of tools that can help make their lives easier. Our volume browser is where we pull up a lot of model data. And so, here's a lot of the model families that they have available for forecasters to look at. Observations, again, METARs, ground truth, maritime buoys, all of the warnings that are currently in effect, you can pull up. Local storm reports, lightning data, fog monitor. I mean, there's so much here in terms of observational data. The SPC convective outlooks you could overlay, hurricane track summaries. I mean, a lot of these menus I've never even touched before, to be honest. And so there's just so much information that is at the fingertips here. Lapse data, some more model data. Upper air, we have the balloons that go up twice a day and sometimes more frequently. And so, the Oklahoma City office, issued an 18Z sounding that we could pull up here if we needed to look at it for this case. Satellite data, whole menu just on satellite products. And then everything after that, these are all the individual radars that are important for this office. I should point out that we are the Norman forecast office for this case. And Norman issues all warnings for everything within this blue border. So I'm going to make that thicker. So all of the counties in this blue outline here, those are the counties where the Norman Forecast Office is responsible for the warnings. To the east, they have Tulsa. To the south, Dallas-Fort Worth, as well as Shreveport to the southeast, and Amarillo. Who else is there? I'm blanking. Lubbock, wherever. They're all over the place. To the north, we've got Dodge City, Wichita. And so they just want the radars that are needed for them. So the program can pull in the radars that are their dedicated radars. So Norman has 3 88Ds, Frederick, Twin Lakes, Vance, and then a terminal Doppler radar near the Will Rogers Airport in OKC. So it's called TOKC. And so all of these have so many products within them. You can see, Z, reflectivity, velocity, storm relative motion, spectrum width. All of these that are specific to the radar. And then there's some derived products that you can pull up, and some other built-in products that are available. And then MRMS, again, this is Steve's expertise. There's a bunch of MRMS products available in terms of, these are all the hydrologic tools in the Flash suite. There's also hail products, lightning, precip estimation, reflectivity, velocity, and so on. And then again, more specific tools. The scan menu just holds a bunch more tools that have been developed to be integrated directly into AWIPS. And then local maps that might be useful to a forecaster, things like interstate overlays, local lakes. They can make large event overlays so that they know where their major stadiums are, their arenas, so on and so forth. And city boundaries, those sorts of things. So as you can see, a lot of information at their fingertips. So there are these things called procedures that we create that are kind of bundles of, a forecaster can create whatever they want, and make it look however they want. You just saw that I changed the line width to make the boundary look the way I wanted. You can see that it's blue because I made it blue the way I wanted. They have so much functionality here. This particular bundle that I pulled up, there's a lot of information here, but it has velocity, it has storm relative motion and reflectivity. It's got some bunkers, right and left moving wind barbs. It's got all of the local warnings if there is something issued right now. And so this is just one potential bundle that you can have pulled up. I can open a new tab and I can show you what, say, a 9 panel looks like. You can see here's a flash flood bundle, and here's a severe bundle. And so when I want to go look at this radar 9 panel, you can see that the forecaster can pull in a bunch of radar products all at once. Some are straight from the radar, like a lot of these dual pole products people might be familiar with. This one down here in the lower right, is an estimated hail size. That's a derived product that comes from the MRMS suite. And they can have rotation tracks, lightning data, satellite data. They can make these bundles really show whatever they want it to show. And so, I just wanted to show you just some of the true functionality that the tool can bring in before I actually showed the warning decision. And so with the last few minutes that I have, I want to show kind of how they go through the process of issuing a warning. So we see our supercell here, it's bearing down on Oklahoma City. This particular bundle has both reflectivity and storm motion. And so they would, kind of use this to track the velocity couplet. It looks like it was just pretty strong going right through Bridge Creek. Those of you might remember this case from 2015. It's May 6, 2015. And so very strong supercell going right up I-44. At this point, it just hit Bridge Creek, and it looks like it's starting to weaken, maybe occlude into a new couplet that might develop off to the east. And so we'll open WarnGen here. Someone was asking about WarnGen. It's literally just a little button right there. And it starts off with this drag me to storm. And so before we do drag me to storm, we want to pick which product we want, because that's going to affect what shows up on the screen. So we're going to say that we're interested in doing a tornado warning, and we're going to set our duration to 30 minutes. That's the default. And now we're going to drag it to our storm. So we're going to put it right over the couplet. And because of the product that we picked and how long we picked it, it starts with a default polygon, and it starts with a default vector. And then it's our job to figure out, well, how fast is this particular storm moving so that we can change that vector and then ultimately change the size of the polygon. And so we just go back a couple steps and we see that our little dot, which might be hard to see from a distance, is sitting right here, whereas we can see our couplet is actually right there. So I'm going to pick up and drag my dot closer, and all of a sudden you see how my arrow shrunk, and it changed direction based on kind of the progress that the storm has made. And we can see now that dot is actually tracking much more closely with that couplet. And something that, again, someone might be noticing here is it's still a strong couplet, but it also still might be having a more northerly track. I mean, I know this case enough to know that it's going to take off to the north here in a minute and redevelop to the east. And so using kind of the overall storm motion and seeing even just reflectivity, hey, if I just track this couplet, look where the new one's starting to develop. It's actually developing over here. And so having both of these tools together, you can see that the new hook is here. The overall storm motion is more, northeasterly versus the vector that I have. So, again, forecasters would be kind of figuring out which part of this tool they want to use to track the most, to ultimately get the motion that they're looking for. And that's what these little wind barbs are on here for too. They're showing the overall storm motion, not just the couplet and the hook echo that can kind of vary quite a bit. They're using these wind barbs to kind of get a general feel for the overall motion of the storm. And so while it doesn't track the current couplet, this to me looks maybe much more indicative of where the redevelopment is occurring. And so now that I'm happy with that storm motion, I'm going to hit track, and it's going to repop my polygon to match my current vector and my current length duration. And so now I get to play with it. I get to say, all right, I don't think it's going to move all the way down there. I'm going to pull it in. I'm going to let it still cover where, my potential hail core is. I'm going to give it a little bit of room on the back end for any kind of RFD winds. And then, the vector says after 30 minutes, it's only going to be right where the tip of this arrow is. If you can see that a little bit better, that's where the 30-minute arrow is. And so maybe these are a little bit too far. Maybe I want to, pull these back a little bit and see, we don't want to have too much overlap when we have our storms moving. And so, maybe that's more in line with what we want for right now. And so I don't want to play with it too much. Again, time is of the essence. This tornado is bearing down on the metro. And so I'm happy with that. And then now I get to make my text selections. Over here, here's where you have tornado emergency, the considerable tag, which makes it a particularly dangerous situation, and then a base tornado warning. And so let's just, for the sake of it, I mean, we can go up to considerable tag. There would be parameters that we'd be looking for in terms of velocity to say that, oh, and we got a new SPC mesoscale discussion. So thank you, SPC. And so, let's just show what a considerable tag looks like. Have we gotten any reports? What's the basis of our warning? It defaults to Doppler radar indicated, but let's look and see. And so has anything come in? It doesn't look like we've had a report for quite some time, actually. We don't want to use too old of a report, because tornadoes can change very quickly. So the last report on our storm came over 30 minutes ago. And so I'm not going to use that to verify this warning. I'm going to say it's Doppler radar indicated. They would also, a forecaster would be doing some hail assessment. And so let's go ahead and just pick a hail size, assuming we had already assessed it. I played softball. Let's give it some softball size hail. If you had reports, we'd select this to include the report information. We always like the list of cities in our warning so that it reads over the weather radio as such. And then we have these things called call to action statements. It's just what we want at the bottom of the warning to relay over the weather radio and in the report or in the warning text itself. Usually you can go with a default if there's something else important, maybe this one because it's going down I-44. I'd want to say, pick the one that talks about safety rules for motorists. Maybe if it was rain wrapped, I would have picked that one. We generally say 1 to 2 for forecasters so the warning doesn't get too long. And that's everything. And so we would cross-check all of our details and then hit create text. And so at this point, this is what it would look like over your weather radio. The National Weather Service in Norman has issued a tornado warning 4. It gets the counties auto-generated from where your polygon is, and it gets the details from where you put your track. At our current time, a large tornado was located over Newcastle, moving northeast at 30 miles per hour. It knows that because of where we put our dot and what direction our vector is going. It has particularly dangerous situation because we made it a considerable level warning, hazard tornado, radar indicated rotation. These are auto-generated impacts. Here's our list of cities, again, based on the polygon. And then our call to action statements, where you can see my selection of the motorist one puts in this motorist paragraph. Looking down at the bottom, tornado is our threat, radar indicated, damage tag considerable, and our hail size of 4 inches. And so want to make sure all those details look good. And if they do, I'm going to sign it. I'm just going to send it. And after I say, yes, I'm sure I want to send it. Yes, it's going out to the world. This is when everything, AWIP sends it to the world. AWIP sends it out to all of the wireless emergency alerts. It goes to the media for display on the TVs. It goes over the weather radio and to any other partner that needs it. And so it just gets pushed out. After that, we hit restart, and you can see our polygon now displays, and we've issued a warning. And so if a forecaster now wants to update it, all you simply have to do is click this severe weather statement and right click the polygon. And at this point, I would be able to then change a lot of these details, trim it up, change the path, and change details here if I needed to change it to an EM reported, all of those details, click create text, and then kind of reissue that updated product. So that's kind of how you do the follow-up side of it as well. So I know I just went a few minutes over. So if there's time for questions, I'm happy to take them. If not, people can reach out to me at a later time.
Well, this is fantastic. Thank you, Jill. And we have time. We have plenty of time, so we can open the floor up to questions to here in the room or online.
Well, Jill?
Mm-hmm.
Yeah, my name's Stanley Christmas. I retired in '99 from the Weather Service. And I just got to say, I am astounded at the development and the updates on issuing a warning.
Absolutely. Absolutely. I mean, even in the time that I've been here, just the advancement in not only the AWIPS programs, but also the data that feeds into the decision making. Yes, it's amazing.
And I really appreciate you going into detail on this.
Happy to do it. We love this kind of stuff. I mean, it's, we participate in the National Weather Festival every year, and it's amazing to talk to the public and realize, just how little they know about this end-to-end process. They just see the polygons on their TV and think the media issued them sometimes, and just explaining to them, no, there's the National Weather Service and they're doing what you're doing. I mean, we literally let the public do what I just did, sit down and draw their own polygons and see the process. And it's fun for me to have that opportunity because it really enlightens a lot of the behind the scenes and the service that the forecasters are doing for the public.
Other questions or?
This is incredible.
I'm happy you all enjoyed it.
Yeah. Well, Jill, I can obviously ask a few questions here, and don't worry, too hard. Yeah, I know. So you talked about changes in technology since you've been there for the last 8 years now. Have there been any big noticeable changes in like training philosophy since you have been a part of this effort?
Training philosophy. I know, there's adult learning concepts are, I think in general, growing, like what's appropriate for adult learning is something that we do take into account as we develop training. And so things as simple as, best practice says, don't make a lesson that's longer than 30 minutes. People are going to get bored. Something as simple as that. Adding animations to your slides, because again, if someone's staring at a slide for more than 30 seconds, they're going to tune out and start looking around the room. So like, how do you maintain attention? there's a buzzword, gamification. This is a form of gamification. It's adding interaction to your lessons to, again, give people a chance to play a game, right? You know, maybe a lot of us like playing Wordle, and you're learning words. I play one called Worldle, where you actually like get outlines of a country and you have to pick the country. I'm learning world geography because of it. It's gamification. They're teaching me something. And so we try to do the same thing. And so I think that's definitely a place where the technology and the tools out there have advanced enough where there's more ways to play those games effectively for what we need and add interaction to our lessons, to our webinars, that sort of thing. The technology that we have even in our simulator has been able to improve enough to add even more functionality for, again, forecasters to practice issuing different types of products or looking at different types of data. But so I don't know if that quite answers your question, but we're trying.
No, that's great. That's what I was aiming at. Like, going from the how do the lessons evolve to the simulations, and so you spend quite quite a bit of time here explaining the different processes of tracking the storm, the motion vector, how to manipulate the polygon and everything you want to see in there. So when you train a forecaster, like in the end, how fast do you want them to be to do this entire process?
We say that ideally that they could do the end-to-end process in 2 minutes, that you could hit that orange end button and drag that little dot to the storm and go all the way to actually issuing the product in under 2 minutes. And so, by the end of our workshops, there are folks that can definitely do it that fast. Because again, once you get used to just the process, you get your flow down. To be fair, they're supposed to have done the decision making before they open the warning program. So I should say, like I said when I was going through the list, it's you don't get to the hail section and then decide, oh, I don't know what hail to put in. Let me go do that. Because by the time you go and do your hail analysis and look up in the tilts of the radar and down and whatever, now all of a sudden your polygon is going to be out of date because you've just let a couple volume scans of information come through a few minutes, and all of a sudden it's trekked forward. And now you've got to change your vertices. And so we always tell forecasters, you should go into a warning decision having decided, is it a tornado or severe thunderstorm? Is it confirmed? Is it, what hail size, what wind threat, all of that. So that once you get to this point, it's just drawing the box, doing the text, and out.
Nice. All right. Last question, easy question. What's been your favorite case to your favorite West case so far?
Oh man. This one actually hits deep because this event I was personally affected by, because in about 20 minutes, I think it goes right over my house. And so I was home at the time and we didn't have a shelter at the rental property I was in. So I remember being home when this starts looking pretty bad heading into Norman. So training on this case reminds me again all the time how that felt, especially as this case unfolds into a major flash flooding case later on. The worst flash flooding I've ever seen in Norman, hands down, and just the impacts from all of that. So this might be actually my favorite.
Okay, yeah. When you said the case date and I saw this, I was just reminded because Ashton and I were probably 5 minutes down the road watching that happen. So fun times. So Jill, thank you so much again for doing this, for our group presenting, giving your presentation in this great demonstration. So as we close, yeah.
Thank you for having me, Steve. I appreciate it. And feel free to share with them the webpage that we have where our training exists and my email address. If anyone has any follow-up questions, I'm happy to answer them.
Yeah, I have that written down. I'll follow up with the group on that. Thank you. Mm-hmm. So just to wrap up some chapter business real quick before we adjourn. First, Jill, next time I come to Norman, I will have a gift card for you for doing this. So thank you, Kent. This is how we roll, Jill. This will happen. I will find you. So things are coming up. So Stanley and I were talking about this on the way here. Science fair will be, around the corner next year in February. So we will be, us officers will start talking about that, how to get back involved with the community with that. I believe was both what Dallas and Tarrant counties,
Fort Worth.
the Dallas and Fort Worth ones. Membership and dues. If you want to join in and haven't paid your dues yet, the information is in our emails and online on the chapter webpage. And last order of business is, before we adjourn, is our next meeting is going to be Tuesday, December 13th, 7 p.m. Again, we're still in the alternating location, so we'll be at the North Texas Council of Government buildings in Arlington, right next to Six Flags. And our speaker for that month is going to be the internationally renowned Dr. Harold Brooks from the National Severe Storms Laboratory. So it'll be a very interesting talk there. Unless there is any other items that need to be had or talked about.
Nope.
Dave, are we good?
I think we're good. I really enjoyed this talk. It was very informative.
Yes, it was. Jill, you did a great job.
Oh, yeah.
So with that, meeting's adjourned. We'll see you next month. Y'all have a good night.
Have a good week, everybody. Thanks.
Okay, good night.
Thank you again.